everyone, in this video we will be looking at designing a feed system for any social media platform. So it can be something like Facebook or Twitter. Let's start with the functional requirements. In the functional requirements, the first one is user should be able to create or view posts and tweets. Second one is user should be able to follow other users. Third is user should be able to view posts from other users in a chronological order. By chronological order, I mean that if we have a feed and we have various posts over here, if a post was made at like today and at 10 p.m. and there's another post that was also made today at, let's say, 9 p.m. So this post that was made at 9 p.m. should be behind in the scrolling. So this is your down scrolling and it should be behind this particular. So the latest post should appear first on the page and then the older post should be appearing. Fourth is user should be able to search for the post. So we can have a search box on our platform, like you have seen on X or Twitter or the Facebook, where you can search for a post and you can enter any text. So this search should be a full text search. Full text search, I mean, is if you have something like if you have a post where you have user should be able to create post. This is your post, let's say, for example. And if the user search for something like create post, then he should be able to find this particular piece of post that is created. And if the user types something like user plus, if the search query is user and then create and then post, this should also retrieve this particular document. So you can see the words that you are searching can be in any order anywhere in the document. Next is the non-functional requirement. And for the non-functional requirement, we already know what we look for this. We look at three things: the scalability, or I'll just write scale over here. And the next thing that we look at is the availability. And basically you are looking for something like a cap with scalability and latency. So availability, partition tolerance. So partition tolerance, we generally not talk about in the system design interview that we have. The reason for that is partition tolerance is almost always assumed that your system should be fault tolerant in a way that it should handle partition tolerance. You should have a scalable, available, highly consistent. That depends on the use case, of course. Consistent and low latency system. So low latency is also one of the requirements. Now let's start with this. First one is the system should support low latency feed viewing experience. So we have the keyword low latency over here. Second is system should prioritize availability over consistency for feed. So note that specifically for feed, we have mentioned that we want to prioritize availability over consistency. So this is very important. You should not just write, hey, the system should be consistent. Hey, the system should be available. You should give the area of the system that should be highly available or consistent. And here we have said that availability for us is more important than consistency for viewing a feed. Next is low latency full text search. So this I've talked about. What is a full text search? And low latency, you know that it should be quick. So something like less than, let's say, 100 ms is quick for us. So that you can define for your system. Here I have just given an example of 100 milliseconds as quick. Next up are the core entities of your system. So starting with the first entity, which is the user. The user will have a user ID. Next entity is follow. See, you will see one thing that I have only mentioned, the user ID. I highly believe that you should not waste time in adding something like a name, an email, and so on. You can just say, hey, the user has a user ID and it has some other attributes. Don't waste your time in listing down all these attributes in the interview, right? And next entity is the follow entity. Follow will have a follower. So follower is a person who follows and followee is the person who is being followed. So if a user A follows a user B, here A is the follower and the B is the followee, right? So this is how I have created the follow entity and you have created that. So just to track when this user started following this particular another user. Next is the post entity. So in the post entity, we have ID, content, author ID, and the created at timestamp. So these are all the things that belongs to the core entity of the system. Next up is the API design. So in API design, we already know how we do it. We start with your functional requirements. You start with your first functional requirement, design an API for that, go to the next functional requirement, design an API for that, and so on. So the first the functional requirement that we had for our system was to create, post, or tweet. For this, we will create a post API. And the reason why we are creating a post API is simple over here, because we have an API which creates an entry in the database. That's why we are doing a post call here. Next up, we have the API path, which is /API/v1. This is the versioning that we have. Then the last path that we have, which is /posts. In this, we have the request. So the request will look something like this. It will just have the post. So this is a post. And the response will be just 201 created. And you can also pass a post ID. The reason we are passing the post ID is because if the front end or the client wants to redirect the user to this particular post after it is created. Next API design is follow other users. So we will create a put API. The reason why we are doing a put API over here is we want something known as idempotency. Idempotency is the reason why we are making this API put. If the users by mistake clicks the follow button like multiple times, then we want that the users should still follow the other user. For the unfollow, we can have a different API with the delete or some other method type. So it can be something like delete and then the /unfollow API, something like this. We are not going to cover this API in our use case right now. So for idempotency, the put request is idempotent. If you create a resource using put and then you send a put again, then the idea is you do the same update on the same entity, it should be idempotent. Request structure looks like this. We have the follow ID, so the user 123, and the response is 201 created. You will see we don't have the follower ID. You might be thinking, why don't we have a follower ID in here, right? The reason why we don't have a follower ID is because we can take that out from the JWT token or anything that you are using for authentication. You will have a JWT token that in that you can store the user ID itself and you can take that out as the follower ID. So someone won't be able to misuse this API by, hey, I'm passing to this API the follow ID. So someone can really misuse this one, that follow ID is user 123 and they can pass the follower ID to something like my ID 1 if it is my ID. And you can follow multiple users using this IDs, right? You can create a way in which someone can misuse this by having a lot of followers in this scenario. That's the reason we are not passing the follower ID here. Right. Next is the view feed API design. The view feed API design will look something like this. So we have a /feed and we have size as a query parameter. And then the after. This after we will see later probably in the deep dive section, or I will give you a brief introduction to this one right now. Response. So response will look something like this. You will have the list of posts and you have a next after and a timestamp. So let me explain what this after means. Let's say we have this particular feed over here. This is post P1, P2, P3, and so on to P10. Let's say the size is 10. And after timestamp, initially when you are calling, you will give it a now, whatever the date time that is now. What after means is, hey, you are saying to this API, hey, give me all the records that are after this particular timestamp. So once you are done with viewing like P1, P2, P3 and up till P10, whatever the created timestamp created at of this particular entry will be, that you will pass in the next after. So here you will pass this one. And after this, when your client makes an API call, initially it will pass now. And then after this, it will start passing this next after. So whatever next after it gets in the API, right? Whatever timestamp. The reason for that is once the user views this and these all posts, now it wants to fetch all the posts that are after this particular last post. That's why we are passing this after parameter over here. So by this, you can maintain the chronological viewing order. You shouldn't have a post in between here where you will find something that was recently created. You are showing the user the feed in a chronological order based on the created at time. So now let's move on to the high level design part of the interview. We will start again with our functional requirements. And the first one is create post /tweet. In this, we have a user over here. We have an API gateway. The API gateway will do the routing, the authentication and load balancing, right? These are your key things that the API gateway handles. Then it will make a request to the respective service. Here for create post and tweet, it will be the post service. And then it will make a call to the database over here to store the post. This is a very simple design, of course, because we are still trying to convince the interviewer that, hey, this is our simplistic design. And then I will deep dive into each and every non-functional requirement and clarify that with you. High level design is as follows for the next one, which is follow other users. So for following other users, we have created a separate service. The reason we have created a separate service is simply because we want to scale the follow service differently as compared to the post service. So we are using a microservice kind of an architecture over here. And that's why we are using a separate service for follow. Next, we have the view feed experience. So for the view feed, we have created a feed service. And again, the reason is same. It has a different scaling needs than the post service and the follow service. The last part of the high level design is search posts. So in order to search the post, you have created a search service and then you can call the database over here. One thing that I think I've missed is the API design for search. So I'll just quickly go to my whiteboard and over here we can probably start drawing some things. And okay, so we are working fine here. We will create a get endpoint and we will call it something like /search. And then we have our query, which will be the search query itself, right? This is how you can do your search endpoint. And in the response, what you will get is the list of posts, and you will also pass a page and a size over here, right? These are the two more query parameters that we have. So quickly jumping back to our search service, it is a very simple design over here. Let's move on to the deep dive section now really quickly. So this is the main part of our interview, the deep dive section. We will start with our first non-functional requirement, which is low latency feed. And I have highlighted this in red, the feed service. The reason why I've highlighted it is this is the bottleneck for a low latency feed. So let's see how you can generate a feed simply. So I'll remove this and quickly come on to the whiteboard. We can simply have something like, let's draw our entities. One of them would be something like post. So we have a post P1, P2, P3. Right, something like this. And after this, we have followers and followee. So you have follower and followers, F1, F2, F3, something like this. And this in turn will be follower and the followee, right? Something like this. So user A, B, C, and XYZ. Something like this. Now let's say I am user. So we have taken the follower as ABC. So I'll say I am user ABC. How do we get the feed for this particular user? So simply how you can get the feed for this user is, so we get the user feed ABC by the following action. You can do something like select all the followers for this user ABC. And so what you will do is you will get all the follow entities. So in order to generate the feed for user ABC, what you would want is all the followers, all the users that ABC follows, you want to get those. You can simply query the follow entity for that part and you can get the users. So let's say user 1, user 2, and user 3. And now you can simply do a query in your post table. So in the post table, what you will do is get all the posts where author ID in this list and sort it by updated or created date time. I'll say updated at in a descending order. So this is how you can get the feed. And the problem with this is it's really, really slow. You can't do this, you scale this on a large number of users. When a particular user has a lot of followers, you can't scale it pretty well. So what are the approaches that you have? Let's see that. So before we move on to this design, that we have this really sleek looking design, we will see what all optimizations we can do on top of it. So let's start with the first option that we have. So option 1 to optimize this particular approach would be something like using a cache, for example. You can use a cache. What you can store in the cache is a list of posts. So you have a user ABC, that is me, and you guess the followers. or the followee. And now you want to see the list of these followers. I'll write follower, right? You get these followers that user ABC is following user 1, 2, and 3. Now give me all the posts by these users 1, 2, and 3. What you can do for a small time, you can cache this particular thing. You can cache the feed in such a way that you have to make only this request, and then this second request that you are making in post table, you can cache it. You can store it inside a cache. You can say user ABC is the key, and post 1 ID or post 1, post 2, post 3 is inside a cache. This is one approach. There are several problems with this approach. First is the staleness. So you won't be able to see all the latest post by the follower. So let's say there is a post that one follower just posted, and you want to show all the followees that post. You will have a staleness over here. Maybe the cache is really small, and you cannot cache it for long. You can at max cache it for like a minute or so, but this will ruin the user experience, right? Because the feed is now really slow, which is problematic for us. Third, I think we can think of few more things which are the problems. So these are our problems. Third thing is that even if you are using a cache, there can be a follower which is a user which is following a lot of users, and this will be a problem. So this problem I'll call simply a celebrity problem. Celebrity problem simply means you have a celebrity, of course. You have a celeb C1. Let's say this is something like Taylor Swift, and there are like millions and millions of followers that she has, right? And you are a user ABC. You get to this particular, you are following her, so the celebrity, and you want to see the post as soon as they posted it. And this will be a problem. If you are following a lot of users, your follow table entries are a lot. You have tons and tons of users. So instead of these users 1, 2, 3, you have like thousands and millions of people that you follow, right? How do you show the feed to them? So these are a few problems that are with this design. Second, option number 2 for us can be, one more thing that we can do is we can have something known as fan out. Now, what does a fan out mean? Fan out simply means that, hey, I am this user ABC. Whenever I make a post, you fan out this request. So there is this one request of creating a post. You fan out it into multiple requests that simply says just store this post ID P1 inside the user 1 feed, user 2 feed, user 3 feed, and so on, right? Something like this. What are these users? User 1, 2, 3, 4, 5. These are followers of the user ABC. So these are followers of this user ABC. Now, what you can do simply is in the database, you can have a pre-computed feed where you can simply store that, hey, for user ABC, we have following post. And you can have something like an append only list with, let's say, you will keep at max 200 entries inside this table for a particular user. So ABC, for feed of ABC, we have a post P1 by a user U1. We have a post by user P2, U2, P3, U3, and so on. So basically what you are doing is you're simply storing a pre-computed feed, and on right, you are fanning out to the followers. So whenever there is a post, you are fanning out it to multiple users. And there's one problem over here which we can solve really easily. So I'll write the problems. Problem number 1 is how you are going to handle a user with like, let's say 1,000, just 1,000 followers, right? 1,000 followers user, and he makes a post, right? They makes a post. How you are going to make 1,000 requests at once? So this is a bottleneck of the system over here. In order to solve this bottleneck, what you can do is you can use something known as a message queue. So instead of synchronously making the request to all these users pre-computed feed, what you will do is you will populate a message inside the message queue. You can populate thousands of messages inside this queue, or you can populate a single message and then the consumer would pick it up and try to see what are the followers. So I'll go with the simpler approach over here. What you can do is you can publish a message to this particular queue that we have. You publish a message saying, hey, I am user ABC. I have made a post with ID P1, right? Then we will have a consumer of this particular queue, and the consumer will say, find all users that follows ABC. So this will be step one. Of course, it will be paginated since there can be thousands and thousands of users following each other, right? So this is our first step. Second step is create my post entry inside that user's pre-computed feed, right? So you are just appending it over here, somewhere over here. So this is simple, right? This is really, really simple. You think that it would work. And now we look at the next problem. So second problem is the celebrity problem. The celebrity problem is simple over here. As I have explained it to you, we have a celebrity C1, let's say 1 million followers, right? They make a post P1, and now you have to fan out. Now you have to fan out millions and millions of users, which is not scalable. So how would you go about handling this particular celebrity problem is the approach number 3 that we have. So option number 3 is fan out with pre-computed cache, pre-computed feed, and you do one more thing over here. You do fan in. I'm calling it as fan in. Fan in simply means that you get a request in this scenario. You see the followers and you see the feed, or you see the post, right? So you do something known as I'll simply, instead of writing it to fan out with pre-computed feed, I'll say this is a hybrid fan out. So we do a hybrid fan out over here. Hybrid fan out simply means, let's say we have a celebrity, they create a post, right? Now you have to fan out. So instead of fanning out this to 1 million followers that this particular celebrity has, you fan out only to the people, only to the followers which are active on the platform right now. Now, how would you find what users are active on the platform? That is a different set of problem, but I'm just black boxing that particular thing over here because I don't want to deal with this in the interview. If your interviewer is really interested in this one, you can probably read about this more, how you can have health checks, maybe that this users create a request every 5 seconds that, hey, I'm active, hey, I'm active. That can be one thing. You can have a open WebSocket connection where you can send a message through that channel that I'm active. There are various ways which you can find out how many users are active on a platform right now. You only fan out to these users since they are right now active on the platform. It's high chance that they will scroll down and do like a pull to refresh kind of a thing. And we want to show the celebrity post to these active users first. So here you do a fan out that we talked about in approach number 2. And hybrid means that instead of fanning out to everyone, what happens is you use the approach number 1 for users who follow celebrity, but are not active right now, So instead of creating a pre-computed feed for them, you generate the feed for user ABC. The feed, you will generate that particular feed at the runtime instead of that, right? You can generate it in runtime as we were doing in the first approach, right? Option 1. So this is the hybrid approach. And using this, you can solve almost all the problems. You have to have a way of doing the hybrid fan out by having the number of active users or the list of active users over here. You fan out to them. For other user, you generate the feed at runtime, right? So this is how our approach for low latency goes. We have created a post cache. So what happens is when you create a pre-computed feed, so instead of drawing this one, I will simply show you here. This is my pre-computed feed. You keep the post ID, right? You keep the post ID instead of the post itself. So you will have to use the post service to get the post ID, right? And getting this post every time is not efficient. You can cache this post ID. So you can have a post cache here, which will have post ID with the post information, right? This is what you are going to have. So this is the post cache that we have introduced. Next is low latency search. And this is our queue that we have seen. I'll just go back once because I missed this queue. This is the queue. So whenever someone make a post, you fan out. This is the fan out queue. And the async workers or the consumers, in this case, you can use something like Kafka over here for the queue, and you can have the consumers put the data in the pre-computed feed over here. Next is how you are going to handle the low latency search. For the low latency search, the problem here is the search service, right? The search service is right now using your relational database for doing a full text search. You might be using something like Postgres, let's say, which does a really good full text search, but is not purpose built for handling like tons and tons of posts. Like you can have millions of posts generated each day. So what I would recommend is in this scenario is you use a purpose built search platform, something like Elasticsearch. Have your post indexed in Elasticsearch. Elasticsearch is really, really optimized for such scenarios where you want to do a full text search. Maybe you want to do some sort of a ranking. You can build a tiny recommendation system as well out of Elasticsearch. What you can do is whenever there's a write on your relational database, let's say Postgres, you can configure the CDC pipeline. So change data capture, CDC pipeline for ingesting all the documents from the database, the relational database to the Elasticsearch over here. And then you can use the search service for searching through those posts. So I think this is end of our slides. And I hope you enjoyed this video. This was a detailed video. We have covered these approach. And if you want to focus something on this interview, focus on this problem, the how you will calculate the feed for a user, right? And thanks for watching. Do subscribe and like this video. Thanks a lot.